Welcome to this video on the topic of matrices. In this video, I'll be showing you how you can apply matrix addition and subtraction. Now, matrices of the same order can be added and subtracted together. Notice that I say same order. What this means is that matrices of the same dimension can be added and subtracted together. If they're of different orders or different dimensions, then it's simply not possible. Now consider if we have matrix A and matrix B. Because both of these matrices are of order 2 by 2, or because it's a square matrix, we can just say order 2. These two matrices can be both added together as well as subtracted from one another. Now performing addition in example 1 shown here, what we can do is we can go matrix A, which is 1, 5, 2, 3, plus matrix B, which is 4, 2, 8, 7. The way in which this works is we're going to get a matrix of the same dimensions of the matrices that we have for A and B here, and we're going to add elements that are like for like in positioning. So if we have the first element 1, 1, we're going to get A1, 1 and B1, 1, and we're going to add these two guys together. Again, pay particular attention to how I'm setting this out. What I've done is I've pre-drawn the matrix such that I know the size that I'm going to take up on the paper, and I'm using my squares on the paper to help me guide me in my sizing. The problem with matrices is that we're dealing with so much information, it's very easy to create a huge mess on the paper that's completely indecipherable. So be organized when you're doing these. Now that we've got the first element done, let's go for the second. So I'm going to go for element 1, 2 and 1, 2 in both matrices. This is going to be 5 plus 2 as seen here. Now going for the third, we're going to go element and we'll say 2, 1, so that will be 2 and 8. And then finally element 2, 2, we're going to go 3 plus 7. So we're going to go 5, 7, 10 and 10. So this is our solution here. Now to verify that addition works in both ways, so it doesn't matter whether it's A plus B or B plus A, let's perform it again over on the right hand side here. What I'm going to do is I'm going to set myself up for success and draw a nice and neat matrix arrangement. And now that we're set up, the battle is pretty much over. Performing the calculations, which comes out to be the same as A plus B. So what we can note from these two examples here is that addition of matrices is commutative. Commutative meaning that the order that we provide these matrices in doesn't actually matter about the plus sign. Now going down in example 2 here, we're going to perform subtraction. We're going to use the same matrices, matrix A and matrix B, but rather than adding them together, in this case we're going to subtract matrix B from matrix A. Now, so the way in which this works is exactly the same as addition. However, rather than adding them together, we're going to subtract them. So, to perform the first element, so element 1, 1, we're going to grab the respective 1, 1 elements in matrix A and B, and then we're going to subtract them. So we're going to go 1, take 4, like so. Going for 1, 2, we're going to get 5 and 2, and we're going to go 5, take 2. Element 2, 1, we're going to get 2 and 8. So 2, take 8. And finally, 3, take 7. Once again, pay particular attention to how I'm setting out this matrix and trying to keep everything in the grids. Reason being, once again, is that I want to arrange this in such a way that it's easy to read. You don't want to have a messy matrix because 1, you're going to make mistakes, and 2, the marker's not going to understand what you've done. Now, finishing these calculations off, 1 take 4 is minus 3, 5 take 2 is going to be 3, 2 take 8 is going to be minus 6, and 3 take 7 is going to be negative 4. So this is A minus B. Now, performing the same operation, however reversing the matrices, rather than going A take B, we're going B take A now. We'll set ourselves up for success, draw the matrix in advance. computing this, we're going to get 3. So what you can see is that the polarity between the two here is opposite. So for A take B, we've got -3, 3, -6, and -4. But for B take A, we get 3, -3, 6, and 4. So similar result to what we'd expect to see if we were dealing with scalar values. So just regular numbers like 1, 3, -5, 7. Same principle applies for addition and subtraction, but with matrices. But based on what we can see with the subtraction here, what we notice is that subtraction is not commutative. Alright, now before we go on to example 3, what I'm going to show you next is how you can verify your results using your technology. More specifically, how you can perform matrix addition and subtraction using your graphical calculators. Now, first thing you want to do is you want to clear all of your memory. So I'm going to press F2 twice and delete everything. After that, we hit the exit button a few times to take us to the top menu, and then we're going to, use F3 here to go into our matrix mode. Now what this does is it provides some memory for you to input matrices that you're going to be using on a regular basis. So notice how all of these are currently none. If you have any memory in here, what I recommend doing is press F2 again and clearing it all. Now inputting the matrix, I'm going to go for matrix A. So I just click execute. And then because we're working with a 2x2 matrix, I'll go 2 by 2, enter, and then I simply add the matrix in. I'm going to go ahead and do the same for matrix B now. Once I'm done, I'll click exit to go back to the top menu, and my matrices are now inside the memory of the calculator. Now next step is we have to navigate through a few menus to be able to get to the option to be able to do matrix addition and subtraction. So to do that, I'm going to click the option key once, and then I'm going to click on F2 again for mat vect. This will give me all the options for doing matrix arithmetic. Now when I want to reference a matrix, all I need to do is press F1 followed by alpha and then A. So I've been able to access matrix A. Clicking execute, it's going to provide me with the memory or the values that I put in for matrix A as seen over here. Now to be able to do addition, all I need to do is F1 alpha A plus F1 alpha B. Hitting execute, it's going to show me that the addition between A and B is indeed 5, 7, 10, 10. Doing the same again, we can go mat B plus mat A. What you can see is that the values are indeed the same. Going down, we can verify our subtraction. We can go -3, 3, -6, -4, followed by 3, -3, 6, and 4. So what you're able to see here is how you can use your technology to be able to perform this matrix arithmetic for you. Now, final question in example 3. Notice that we have an interesting example. We've got a 2x2 matrix and a 2x3 matrix. Remembering that in the very top, in our definition here, we can only add and subtract matrices that are of the same order to one another. So because these two matrices here are of differing orders, we don't actually get a solution for this. So in our case, we don't have a solution for this. Now, showing that this isn't possible in a calculator, what we can do is we can go back to the top menu by pressing exit a few times, and I'll go to mat vect, so F3, and I'm going to throw this into matrix C over here. So we'll go a 2 by a 3. Now I won't worry about putting the values in because the values don't matter because we can't actually add these together. So going back to the top menu, if I try and go option mat, like so, plus. So if I try and add this 2x2 and a 2x3 together, the calculator will throw an error at me, which just shows that I've tried to do something that's not possible. So in summary, what we set out to do in this particular video was have a look at how we can perform matrix addition and subtraction, and then we had a look at how we can verify our results on the calculators.